Welcome to Pre-Calculus with Miss Niskern, and today we're going to talk about finding inverses algebraically. We already saw that in order to find inverses, we just switch x and y. That's an ampersand and y. So we're really just going to switch x and y. That's because an inverse is really a reflection over the y-axis. So, y-axis. Oh, silly Niskern. No, inverses are really a reflection of the line y equals x. Okay, so in order to find them algebraically, we're going to basically follow these steps. So we will need an f of x. So we've got this f of x is equal to 2x plus 3. So this is the equation we have. Step 1. Write f of x as y. So we have y equals 2x plus 3. Step 2. Switch. So there it is. It's the inverse, so we're going to reflect it over the line y equals x. Switch x and y. Now, if it weren't linear, and it had a whole bunch of x's, we would have to write x one time, and we would write y a lot of times. Okay, step 3. Solve for y. So we're going to go through the steps of solving for y. So we would subtract 3 from both sides. We would then divide by 2. And depending upon the course that you're taking, you may have to split that up. So I'll write it just in case, because it is an important fact that you really should know that 2 does get distributed like to those two things. And then the fourth step is to rewrite y as f inverse of x. So I'm going to keep with this fraction here, the big one instead of the little ones. And this is the inverse. Okay. How do I know I have the inverse? Well, remember, we've already talked about it as being a composition of functions. So if f of f inverse of x, so I take this answer and I plug it back up at the top, is equal to x, and f inverse of f of x. So I take the other one at the top and I plug it into this, equals x. Then you have inverses. Okay, so we're going to check that here. So our first f of x was 2x plus 3. Our f inverse of x is x minus 3 divided by 2. And we're going to do f of f inverse of x. So that means we're going to do f of, we're going to plug in the inverse into this. But f was 2x plus 3. And this one I am death about. I don't want to see a bunch of cancel marks. I want to see it step for step because I want to make sure you actually know what you're looking at. So we divide the 2's, which do not cancel. They divide out and become 1. And I get x minus 3 plus 3. But this minus 3 plus 3, that ends up adding out and becoming 0. It's not a cancel. It adds to 0. So I want you to know what that is. And so we have that this is true. F of f inverse of x is equal to x. Okay, so that's true. So that's the first half. But notice the if statement had an and. We have to be able to do it both directions. So we have to do the other composition, the f inverse of f of x. So we plug in f now, which was 2x plus 3. into the equation x minus 3 divided by 2. And again, I don't want to see a bunch of cancel lines. I want to see things in order, because then you may not understand what order they went in, and that can cause a problem. These parentheses not doing me any good. There's no exponent, no number multiplied behind, no number in front, so I can pretend they're not there. I see a 3 and a minus 3. That adds to 0. And so I'm left with 2x divided by 2. 2 divided by 2 is 1, so I'm left with x. So f inverse of f of x is equal to x. These are inverses. That's pretty much all you do. So we're going to look at a second example. What happens when I have a situation that looks like this? Oops. I want to leave space for the steps because I'm going to rewrite the steps one more time, because you need to be able to remember the steps. If f of x is equal to x minus 2 squared, step 1, rewrite f of x as y. Step 2, switch x and y. Again, if there was more than one x in some more significantly harder problems, we would have to put y everywhere we saw the x's, or where they used to be. 3, solve for y. Basically what we're doing is we're undoing the function in the first place. So in order to get rid of the square, we have to take the square root. Now, I do have to ask the question, because when I do this, this is a place where it undoes it. So I'm just left with what's inside, because there were 2 of them as a factor. So that comes out. But when I come here with this x, do I need the positive or the negative? So I'm going to do a quick side note. And I will do this in class, and I have done this in class. What's the square root of 9? People will tell me 3. And I'll say, no. They'll tell me negative 3. And I'll say, no. And then it will go round and round for a few minutes before they realize they have to tell me plus or minus 3. Without context, you have to remember to put the plus or minus, because you absolutely do not know. So here I have a problem of a plus or minus piece going on. So when I add that 2 to both sides, I've got 2 plus or minus the square root of x, which is equal to y. But this means that I have a problem. I will either have 2 plus the square root of x, which is equal to y, or I will have 2 minus the square root of x, which is equal to y. And that's because this function is not one-to-one. So the inverse is not a function, and that's being displayed right here. Because the only way we can actually write this is if we take, if we add domain restrictions. So these are our 2 answers for the inverses, and they'll work out when I plug them all in. Everything will be fine when I take care of that piece. But I won't know which function to use unless I know what the domain restrictions are. But that is how you find inverses. Zoom out. That's how you find inverses algebraically. Ooh. Just like that, all in one shot. Thanks, guys.